Hello, good day. In the previous video, we were able to read to our hearings the abstracts of the research. So we are moving to chapter 1 of the research. This is still the previous section. So this is the chapter 1. Chapter 1 Introduction Background. Greenhouse gases are a group of atmospheric gases that are the fundamental reason of greenhouse effects. The major greenhouse gases are carbon dioxide, methane, nitrous oxide, water vapor, ozone, CFCs, and sulphur hexafluoride. Each of these gases has a specific effect on the atmosphere, measured by the global warming potential (GWP). Moraib et al. 2004. The global warming potential relates to the greenhouse gas lifetime in the atmosphere and the efficiency of the molecule as a greenhouse gas. Greenhouse global warming potential is measured on a 20-year scale or 100-year scale and relative to the mass of carbon dioxide. The global warming potential of greenhouse gases is presented in table 1.1. This is table 1.1 relative global warming potential and lifetime of greenhouse gases. Global warming potential for 20 years, global warming potential for 100 years, and this is the lifetime years greenhouse gases that is involved. Greenhouse gas lifetime in years. This one global warming potential is 1, it is 1 year too, and methane it is 12 for lifetime years and 72 for global warming potential, while for 100 years global warming potential is 23. Nitrous oxide is 114 lifetime years and 289 for 20-year global warming potential and 296 for 100-year global warming potential. CFCs, these are the values for this. The atmospheric lifetime for CO2 is variable due to the various rates of its removal in different processes. That is why it is asterisked here. Because of the increasing rates of greenhouse gas emission in the 20th century, UNFCCC developed an international agreement to control the release of greenhouse gas concentration in the atmosphere. According to this protocol, all countries should control the amount of greenhouse gas production. Bowen et al. 2008. Canada is one of the countries that contribute to the emission of greenhouse gases via numerous sources such as energy production, industrial companies, wastewater treatment plants. Pulp and paper industry, an important industrial source for greenhouse gas emission in Canada, is a water-demanding industry and an important source of wastewater. Every day, a large amount of raw water is consumed by the pulp and paper industry. Several types of pollutants can be distributed to the environment through the liquid effluent of the pulp and paper industry. Wastewaters from wood preparation, pulp washing, pulp bleaching and paper making as well as black liquor from the digesters house carry biochemical oxygen demand, chemical oxygen demand, AOX and volatile compounds as the common types of pollutants. Due to the fact that a large quantity of the produced wastewater in Canada originates from the pulp and paper industry, the presence of wastewater treatment plants is essential for dis industry to inhibit the spread of pollution. Wastewater treatment plants have the ability to generate greenhouse gases through several treatment technologies while consuming energy. Wastewater pollutants produced by the pulp and paper industry can be minimized and treated by different processes. These treatments consist of physicochemical, biological, fungal and integrated treatment methods which can be selected based on the type of pollution and operating parameters of the system. Problem statement. This is the reason why this research was carried out. Generally, the type and amount of greenhouse gas production in wastewater treatment plants are highly dependent on the type and amount of degradable organic materials in wastewater. According to international agreements, each sector in industry should estimate the generated greenhouse gases and establish reduction strategies. Wastewater treatment plants should also consider different strategies to reduce greenhouse gas emissions for the protection of environment while avoiding carbon taxes and reducing energy costs. On the other hand, energy requirement and its price is an important key factor in the design and operation of wastewater treatment plants. Energy can be provided from different sources such as electricity or steam, combustion of produced biogas or sludge while contributing to greenhouse gas emission. The estimation of total greenhouse gases produced in Canadian wastewater treatment plants in 2005 was based only on on-site greenhouse gases generation and did not consider greenhouse gas emission due to off-site energy generation or other off-site sources related to the treatment plant. The addition of off-site greenhouse gas emissions can increase the contribution of wastewater treatment plants to the total greenhouse gas emissions of the country. In view of this, wastewater treatment plants are facing the following problems: how much greenhouse gases is generated during the energy production and other upstream sources? Is this amount higher than the on-site generation? How much energy is required for wastewater treatment processes? What is the relationship between the operating and process parameters and the amount of greenhouse emission and energy consumption in wastewater treatment plants? What is the impact of operating parameters variations on greenhouse gas emission? What procedures should be used to reduce the amount of greenhouse gas emission and energy consumption? In order to address these problems, it is essential to propose a new methodology for the estimation of greenhouse gas emission, considering all aspects and conditions of the wastewater treatment process. Furthermore, it is desirable to determine the important sources of greenhouse gas generation and energy consumption in the wastewater treatment plants. Thank you for listening to this video. In the next video, we will be reading loud the objectives of this research. Thank you.